GPT-5.4 Drops, and Knuth Tips His Hat. OpenAI released GPT-5.4 last week, positioning it as a unification play. The coding chops of GPT-5.3 Codex fused with improved reasoning, native computer use, and a new tool search capability that lets the model lazily load tool definitions instead of cramming them all into context up front. On Scale's MCP Atlas benchmark with 36 MCP servers enabled, tool search cut total token usage by 47% with no accuracy loss. A meaningful efficiency gain for anyone building agents that orchestrate dozens of integrations. The model also ships with a 1M token experimental context window in Codex, and what OpenAI calls its most token-efficient reasoning to date, using significantly fewer tokens than GPT-5.2 to reach answers. On OS World, a desktop navigation benchmark, GPT-5.4 hits a state-of-the-art success rate that exceeds human performance. On GDPVal, which tests professional knowledge work across 44 occupations, it matches or exceeds industry professionals in the majority of tested domains. The more interesting signal this week came from Stanford, where Don Knuth, the author of The Art of Computer Programming, published a note titled Claude Cycles, describing how Claude Opus 4.6 solved an open combinatorial problem he had been working on for weeks. The problem involved decomposing the arcs of a specific digraph into 3 directed Hamiltonian cycles for all odd meters too. Knuth's friend, Philip Stappers, fed the problem statement to Claude with instructions to document its progress after every exploration script. Over 31 explorations spanning about an hour, Claude reformulated the problem using fiber decomposition, tried and abandoned DFS, simulated annealing, and serpentine patterns before arriving at a concrete construction that produced valid results for meters = 3, 5, 7, 9, and 11. Stappers verified it up to meters = 101. Knuth then proved the construction correct, showed there are exactly 760 such Claude-like beta decompositions valid for all odd meters. 1. And noted that multiple other researchers extended the result to even meters using GPT-5.4 and multi-agent workflows combining Claude and GPT. One collaborator produced a beautifully formatted and apparently flawless 14-page paper entirely by GPT-5.4 Pro. Knuth's verdict: what a joy it is to learn not only that my conjecture has a nice solution but also to celebrate this dramatic advance in automatic deduction and creative problem solving. AI goes offensive. The shrinking human margin. Chris Rolfe published a sharp essay arguing that frontier reasoning models are fundamentally changing vulnerability discovery economics. For decades, the division of labor was clear. Fuzzers explored program states through brute force, while humans found the bugs that lived in the combinatorial gap. Business logic flaws, complex component interactions, state-dependent vulnerabilities. Reasoning models like Opus 4.6 don't brute force that gap. They reason through it the way humans do, following data flows, recognizing patterns from historical vulnerabilities, and making educated guesses about where bugs hide. The difference is scale. A reasoning model applies this approach across parallel instances at machine speed. Rolfe notes that DARPA's AIxCC finalists identified and patched 68% of injected bugs across 54 million lines of code, while also discovering 18 real-world vulnerabilities that weren't part of the competition. And that was with 2024 5.0 models. The margin humans operate in, he argues, is rapidly shrinking, and the cost of discovery is increasingly just the per-token inference cost of the latest frontier model. Not everyone agrees the margin has shrunk as much as the hype suggests. A practitioner writing under the handle CLAWD pushed back hard, arguing that what AI actually does well, running checklists, identifying textbook vulnerabilities, producing report-shaped text, is useful but fundamentally different from hacking. The Jalokia research he cites, chaining a JNDI injection through proxy mode into RCE and dumping heap memory for credentials, didn't come from any checklist. He points to the curl project killing its HackerOwn bug bounty program after AI-generated submissions cratered the confirmation rate to near zero, and calls out Daniel Miessler's claim that pentesting went from not possible to everyone is doing it as conflating spam with automation. The global penetration testing market is worth roughly $2.7 billion. A rounding error next to the $422 billion US ad market. Of all the industries to obsess over automating, why this tiny one? The practitioner tooling landscape, meanwhile, keeps expanding. A running survey of AI-assisted pentesting frameworks found meaningful differentiation across the category. Pentest GPT covers the widest methodology: black box web, gray box with credentials, and static source review. With both cloud and local model support via Alama. Volhunt, Binarly's open-source binary analysis framework,
now runs as an MCP server for integration with AI assistants, bringing UEFI firmware and binary vulnerability hunting into the agentic workflow. On the reverse engineering side, AIxCC Automate exposes the full AIxCC debugging interface to any MCP-compatible client, enabling natural language-driven debug sessions with trampoline hooks, register manipulation, and memory inspection. A companion Claude Code skills plugin wires it directly into agentic coding workflows. Redimant's penetration testing framework shipped a new insights dashboard powered by Neo4j, visualizing attack chain success rates, CVSS histograms, CWE analysis, and AI agent session activity across engagements. Separately, Vibe Radar is tracking the security cost of the Vibe coding wave, cataloging CVEs and AI-generated projects from May 2025 through March 2026. The tracker already lists shell allow list bypasses, pickle safety hook failures, authorization policy bypasses via display name collision, sensitive file disclosure, and redos via unescaped regex construction. The kind of bugs that happen when code ships without adversarial review.
The harness is the product. Coding agent architecture. Nir published the most thorough public comparison of coding agent architectures to date, dissecting how Codex and OpenCode turn a text generation model into a product across 7 layers: agent loop, context building, tooling, safety, persistence, client surface, and extensibility. The core insight: a while loop and a good prompt can get surprisingly far. Simon Willison's Claude. Dangerously skip permissions. P. Implement X, vertical bar T, a log one-liner built entire programming languages. But the gap between that and what ships in production is the entire subject of this post. That gap is product engineering. Codex compiles its base instructions into the binary at build time and routes all tool calls through a central orchestrator pipeline. OpenCode selects prompt fragments at runtime via model ID string matching and offers a composable plugin registry. Codex is a monolith optimized for tight feedback loops. OpenCode is a control plane designed for multi-client attachment. Neither is better. They're different answers to the question of how to safely let a model act on its own. Zabari's key observation about context: an agent could make hundreds of tool calls in a single turn, potentially exhausting the context window. That makes context management one of the agent's core responsibilities, and in the current model landscape, probably the most important one. Cursor extended the agent as infrastructure thesis with automations, a system for building always-on agents triggered by schedules, Slack messages, linear issues, merged PRs, or PagerDuty incidents. Each automation spins up a cloud sandbox, follows instructions using configured MCPs and models, and verifies its own output. Cursor's own team runs security review automations on every push to main, risk classification automations that auto-approve low-risk PRs and assign reviewers for high-risk ones, and incident response automations that investigate Datadog logs and propose fixes. The framing is explicit: the factory that creates your software. On the CI/CD integration front, a deep dive into Claude Code's pipeline mode, the 9th installment in a series, documented how to run Claude Code non-interactively in CI runners, reacting to PR events, responding to comments, or running on schedules. And a detailed teardown of the /insights command revealed the multi-stage pipeline underneath: session filtering, transcript summarization for sessions exceeding 30,000 characters, haiku-powered facet extraction goal categories, satisfaction counts, friction types, 6 specialized analysis prompts, and a final executive summary, all rendered into an interactive HTML report. The facet extraction prompt alone is a case study in structured LLM output design. Scaling agents, when more is less. A Google research paper with MIT collaborators established the first quantitative scaling principles for multi-agent systems, and the results should make anyone adding agents pause. Across 180 controlled configurations spanning 3 LLM families: OpenAI, Google, Anthropic, and 4 benchmarks, the researchers isolated architectural effects from implementation confounds by holding prompts, tools, and token budgets constant. 3 findings stand out. First, a tool coordination trade-off. Tool-heavy tasks suffer disproportionately from multi-agent overhead because fragmenting the per-agent token budget leaves insufficient capacity for complex tool orchestration. Second, a capability ceiling. Once single-agent baselines exceed roughly 45% accuracy, adding agents yields diminishing or negative returns. Third, topology-dependent error amplification. Independent agents amplify errors 17.2x through unchecked propagation, while centralized coordination contains this to 4.4x by enforcing validation bottlenecks. Performance ranged from plus 81% improvement structured financial reasoning under centralized coordination to minus 70% degradation sequential planning under independent coordination. The framework predicted the optimal coordination strategy for 87% of held-out configurations and generalized to GPT-5.2, released after the study. That error amplification finding resonates with Alan Hamilton's essay on cascading hallucinations in agentic chains. When agents are chained, one researching, another planning, another executing, another verifying. The output of one model becomes the input context for the next, and the second agent has no way to distinguish fact from hallucination. A hallucinated data point doesn't just persist, it gets reinforced. By 3 or 4 agents deep, fabricated premises can drive real-world actions with increasing system confidence. Hamilton argues that current AI governance tooling, built for single-model bias tracking and drift monitoring, is nowhere near sufficient. What agentic systems demand is distributed tracing for AI decision chains. 2 projects attack this governance gap from opposite ends. Context Grapple Gun takes the minimalist approach. 3 commands /cadence/review/siren, flat files tracked in Git, and a scope hierarchy site, domain estate. Federation Global, where lessons captured during agent sessions climb through human-gated review. No embeddings, no vector databases. Just structured JSON-all, append-only audit logs, and a quiet rail signal system that accrues friction volume across sessions and mints escalation warrants when thresholds are crossed. The explicit design philosophy: humans author law, agents execute within it. The gate that fights back takes the adversarial approach. Version 3.7.8 of the AQE Agentic Quality Engineering Framework shipped a sycophancy detector that flags rubber stamp consensus across agents using 4 weighted signals: verdict unanimity, Jacquard reasoning similarity, confidence uniformity, and issue count consistency. When all agents agree too strongly, that agreement is suspicious. Severe sycophancy triggers a devil's advocate review. The system also includes collusion detection, identifying when multiple agents coordinate toward shared conclusions rather than reasoning independently, and adaptive model routing that auto-promotes agent tier from Haiku to Sonnet to Opus after 3 consecutive failures. The author's framing cuts to the core. Until you have a mechanism that actively searches for reasons your system is not good enough, you are not running a quality gate. You are running a confirmation service. Reverse engineering, from Skype's skeleton key to SynthID's naked signal, as Skype shuts down for good. A security researcher published a remarkable memoir of reverse engineering the platform over 2 decades. Starting in 2004, he cracked Skype's custom packer via hardware breakpoints, then built a specialized tool to neutralize hundreds of obfuscated polymorphic integrity checks, each of which used its checksum result as an actual value in subsequent operations, meaning they couldn't simply be disabled. He reverse engineered the signaling layer's RC4 key derivation, built an RC4 key oracle that called the original binary's key derivation function, and created a custom Wireshark plugin to decrypt all Skype signaling traffic in real time. The deeper finding was architectural. Skype's peer-to-peer design let any client be silently promoted to a supernode, creating natural surveillance points. When Microsoft acquired Skype in 2012 and centralized all relay functions onto their own servers, it eliminated the decentralized resilience but gave one entity the technical capability to observe all connection metadata. The researcher discovered memory corruption vulnerabilities in the signaling layer that enabled remote code execution without crashing the client. A digital skeleton key. His reflection: the systems we trust most are often the ones we understand least. In a different register, a researcher on r/local LMA documented an attempt to reverse engineer Google's SynthID watermark using nothing but 200 plain white and black Gemini-generated images, 123,000 image pairs, and FFT analysis. The technique, average enough pure black, AI-generated images, and every non-zero pixel, is literally the watermark signal with no content to hide behind. The community response was mixed. Some praised the creative approach, while others argued the spectral patterns found are artifacts of the Gemini image pipeline rather than the SynthID embedding described in Google's white paper. Either way, the work highlights a persistent tension in AI watermarking. Any scheme robust enough to survive transformation is potentially detectable, and any scheme subtle enough to be invisible may not survive adversarial scrutiny. Purpose-built silicon and the agentic cost curve. Sambonova announced the SN50, its 5th-generation reconfigurable dataflow unit, explicitly positioning it for agentic inference workloads. The pitch centers on model bundling. Sambastack switches between multiple frontier-scale models on a single node, which matters when agentic workflows chain different models for different subtasks. The 3-tier memory architecture, designed so agents can maintain persistent caches for models and prompts across workflow steps. Claims 3x cost savings over competitive chips for agentic workloads. On their hardware, DeepSeek R1671B parameters runs at 200 tokens/second and GPIOS 120B at over 600 tokens/second. Sambonova also positions itself as a launch partner for Meta's Llama 4 series and supports DeepSeek models natively. The timing is notable. As the Google scaling paper shows, agentic token budgets grow quadratically with tool calls and coordination overhead, making inference efficiency not just a performance concern, but an economic prerequisite for multi-agent systems at production scale. For those still building intuition about the algorithms underneath all this infrastructure, a concise visual walkthrough of core ML algorithms. From linear regression through SVMs, random forests, boosted trees, neural networks, and into unsupervised methods like K-means and PCA. Provides a useful 17-minute refresher on the foundations that the entire agentic stack is built upon.